Good morning and happy Monday, Math 8. I will warn you, your exit slip today will consist of your first grade for trimester 3. And the questions are exactly the format we're going to do in class today. We're going to do this video, these exact question formats. And then it's basically the same questions, but like different numbers. So let's get started on this. Follow through this, and your questions later will follow this exact format, but I think the exit slip questions are honestly a tad easier. The numbers are more manageable. So if you find these numbers difficult, just take comfort in the fact that the later on ones are a little bit better. So Laura is an event coordinator, is in charge of room layout for a wedding. The wedding will have 168 guests arranged in tables of 6 and tables of 8. Okay. So we're going to write an equation to model the number of 6-seat tables x and the number of 8-seat tables y that sum to 168 guests in total. So we have x 6-seat tables and 8-seat tables. We have y 8-seat tables. And it sums to 168 guests in total. So sums to 168 means that two things add to get me 168. And what sums get me 168? Well, that 168 is 168 guests. So you have to talk about what has to do with guests up here. And each table, so each X table seats 6 guests. So we have 6 guests per X table, and we have 8 guests per Y table. So there's my equation for that. If Laura has 20 6-seat tables, how many 8-seat tables will she have? So I want you to pause it and try to figure this out on your own first, and then I'll show you 2 different methods to solve this one. So pause it and try to figure out how many 8-seat tables she will have. So we were trying to figure out this. If she has 20 6-seat tables, how many 8-seat tables will she have? So I'll show 2 methods. I'll show one in pink that I expect you to gravitate towards, and I'll show you a new method in some other color if I don't forget. So she has 20 6-seat tables. So we know that she has 20 times 6. So if I have 20 tables that seat 6 people each, that's 120 guests. So we need to seat a total of 168. So if we subtract 120, there's 48 more guests that need to sit at tables of 8. So if we have 48 more guests, each sitting at tables for 8, that means that we need 6 tables of 8. All right, and just for your own reference, this problem and this problem also can go in this table down here. So 26-seat tables gets us 6 8-seat tables. All right, another way to solve that is to use our equation. I'm not picky about how you do this as long as you're logically doing it, because we are going to stick to realistic applications for this. Hopefully it helps you understand it better. So now I'm gonna use my equation. 6x plus 8y equals 168. That's our equation. And I know there's 20 6-seat tables, so 20 is actually my x. So I have 6 times 20 plus 8y equals 168. So we're going to solve an equation now. 6 times 20 gets me 120 plus 8y equals 168. And you all remember solving equations, I'm sure. So subtract 120 from each side, and I get 8y equals 48, and I always run out of room in these solving equations. I tried to leave some room. I didn't. So if 8y is 48, I divide by 8 and get y equals 6. So again, 6 tables. And y represents 8-seat tables. So I have 6 8-seat tables. So I'm going to do the same thing over here for if Laura has 12 8-seat tables. And I'll do it both methods again. I'll say, all right, she has 12 8-seat tables. So 12 times 8 is 96 guests. So she needs to see 168 minus 96 more guests. And 168 minus, well, 168 minus 100 is 68. So then I'll add back in 4. So let's see, that gives 68 plus 4 is 72 more guests. So now I need to take those 72 guests, I need to divide them into tables of 6. And 72 divided by 6, it gets me 12 6-seat tables. So we're gonna go with 12 there. All right, and again, I could set up and solve an equation for this. I'll do that in blue. I'll try to write it smaller. So 6x plus 8y equals 168. That 12 8-seat tables, that's my y. So 6x plus 8 times 12 equals 168. And you'll notice the math involved is the same. My first step is going to be to multiply 8 by 12, just like I did over here. It just looks different. So 6x plus 96 equals 168. And my next step over here was to do 168 minus 96. That's exactly what I'm doing here too. I'm going to subtract 96 to figure out what 6x has to be. And then 6x equals, let's see, again, 168 minus 96. Well, I got 96 both times. That's crazy. So, well, it's not crazy, just kidding. 168 minus 96, subtract 100 is 68 plus 4 is 72. It's not crazy because I'm doing the same math. So then divide by 6, and x equals 12. So I get 12 tables of 6. All right, so it's the same math, 2 different representations. All right, this is the algebraic method, and this is like the problem-solving method that we've probably been gravitating towards in the past. So now I want you to figure out the other 3 combinations. What if there's 0 6-seat tables? What if there's 0 8-seat tables? And try to find your own other combination. All right, we'll go over a couple other combinations you could have gotten. There's a few more that work. I will say there's a lot of decimal combinations. Like if you pick 1 6-seat table, you'll probably end up with a decimal. So my trick for you would be try to pick even numbers of tables, because those will end up working for you. And there's a reason for that, but try to pick even numbers or multiples of 3. All right, we'll go over some combinations later. Give it a try. Try to find the rest of these combinations. Okay, so I actually went ahead and found all the other missing combinations, which is going to be very helpful later. It's something I encourage you to do. And I'm noticing patterns with what numbers I picked. So try to notice a pattern with the 8-seat tables and with the 6-seat tables. So I found that if you have 0 6-seat tables, that means all 168 people have to sit at 8-person tables. So 168 divided by 8 would get me 21 8-seater tables. And the alternative is if there were no 8-seat tables, if everyone sat at 6-person tables, that would be 168 people divided into 6 tables would be 28 total tables. So these are actually like my maximums and my minimums. Like the most number of tables I could have total is 28 total tables. And the most number of tables I could have here is 21, because if I had more than 21 8-person tables, that would be more than 168 people. And if I had more than 28 6-person tables, that would be more than 168. So it turns out I can't have more than 21 8-seaters, and I can't have more than 28 6-seaters. And I can't have less than 0 of each because negative numbers they don't have a place in this problem. So I noticed that 6 and 12 and 21 and 0 are all multiples of 3. So it turns out that in this case, I can only have 8-seater tables in a multiple of 3. If you'd picked like 2 8-seater tables, you would have gotten a decimal for number of 6-seater tables, which isn't really what they want. And if I look at my 6-seater tables, 20, 12, 0, and 28, they're all actually multiples of 4. So it's just an interesting thing you sort of notice. You can only have multiples of 4 up here. So I found the rest of the combinations, and I started with my 8-seater tables. So I found if I had 3 8-seater tables, I ended up with 24 6-seaters. So 3 8-seaters and 24 6-seaters. And that matched, so that was one pair. Another pair was 9 8-seaters and 16 6-seaters. Hi, Sebastian. Another combination is 15 8-seat tables and 8 6-seat tables. Hold on. Sorry, my children invaded my office fighting with kitchen supplies. It was Ted with a tongs versus Sebastian with a baster. So, you know, can only imagine who won that one. So anyway, our last combination was 18 8-seater tables and 4 6-seater tables. And I show the math over here. It's all the same math. I started out putting in my 8-seater tables in for Y. So 3 8-seater tables, that'd be 24 people. And then I did 168 minus 24 to get 144. I'll write that in. And then I divided by 6. So it's really just substitute, subtract, and then divide. And same every time. Substitute, subtract. This one's messy because I messed up first. Substitute, subtract, and divide. All right, and then my other math is down here in pink. Substitute, 8 times 15, 8C tables, gets you 120. Subtract 120 from 168. And I get 6x is 48 and x is 8. And notice, as I have more 8-seater tables, the number of 6-seater tables is going down. And that makes sense, right? If I have more big tables, then I have to have fewer of the other kind of table. So those are all my combinations. All right? Next part. Laura's business advisor, Ava, has advised Laura that she should have 25 tables in total. So we want to write an equation to represent Ava's suggestion. Give you 3 seconds to try it on your own. Pause it if you need to. Okay, it's 25 tables in total. Again, in total means sum. So something plus something equals 25. What two things add to give you 25? Well, the number of 6-seater tables plus the number of 8-seater tables has to add to give me 25. So we have to find combinations of 6-seat and 8-seat tables that sum to 25 tables like Ava suggested. So this one should be easier to do in your head. If I have 0 6-seat tables and I need 25 total tables, 0 plus what gives me 25? Well, 25. And again here, 25 plus what gets me, wait, no, sorry. 0 plus what gets me 25? The answer is 25. And then, okay, if I have 10 6-seat tables and 15 8-seat tables, that adds to 25. 5 plus what gets me 20? 5. Man, I'm giving away answers left and right here today. And then some other combination that gets me to 25. So, like, maybe it's 7 and 18. All right? So we got two different things going on. We have the combinations that get you 168 people and the combinations that sum to 25 tables. And if you've ever planned a wedding before, which you probably haven't, that's pretty standard, 25 tables. All right, so on the next page, we're actually going to deal with the same problem. We're going to create a graph to represent both situations. All right, so we're going to look at our table of values from the previous page for both of them. So let's see, I'm going to go ahead and I'm going to graph the 6x plus 8y equals 168 combinations in pink. And I'll graph the x plus y equals 25 in blue. All right, so I'm gonna plot those points. I'll pause it just so you don't have to watch me plot points for an hour. I'm gonna pause it and we'll see what that graph looks like. So it's important to notice that the first thing I did was label my x-axis as number of 6-seat tables because the x from our problem represents the number of 6-seat tables. And y-axis gets the number of 8-seat tables because we let y be the number of 8-seat tables. So now we're going to plot our combinations. Okay, so I plotted all the points, as you can see in the dark dots, and then I connected them, by the way, without a ruler. Those are very good straight lines for me, if I do say so myself. I connected them both with straight lines, and pink is still the combinations that add up to 168, and the purple is tables that add up to 25. So, which combination meets both of those criteria? Well, it's the intersection point. That intersection point right there, 16 six-seat tables and 9 8-seat tables. And if we look, that actually was on our table before. If you were paying attention, you might have noticed of all these combinations, 16 and 9 right here adds to get you 25. 16 plus 9 gives you 25. So you might have noticed, oh wait, that's 26, 24, 21, 28, 27, 25 right here, 16 and 9. If you thought about that, you don't even have to make this big old table down here. 16 and 9 adds to give you 25. So that's the point we're looking for. So 16 6-seat tables and 9 8-seat tables. So that point is 16, 9. That's my solution point. So 16 6-seat tables and 9 8-seat tables seat 168 people at a total of 25 tables. And I will say, I'm sorry, you couldn't read that. I had to strip the paper. So 16, 9 is our point of intersection. 16 6-seat tables and 9 8-seat tables seat 168 people at a total of 25 tables. And in our last couple of exit slips, and I've had you explain what this point means, I'm not getting phenomenal explanation. So I really want to focus on saying that the ordered pair, 16, what's the 16? Well, 16 is 6-seat tables. And 9 is the number of 8-seat tables. That point meets both of my criteria. That point seats 168 people, and it's a total of 25 tables. So you want to make sure you're saying, why is that point the solution? Why do we care about that? That's the point that makes both of these people's desires happen. It's like the compromise point. All right, the pink line wants 168 guests, and the blue line wants 25 tables. Yeah. And pink wants 168 guests. And this is really the point where that happens. All right, so that's very good. And we're done with that problem.